Today I want to speak to you viewers about a pressing issue in today's society, bacteria communication. As far-fetched as it may seem, bacteria do have their own language. They communicate back and forth from one another, um, from bacteria to other bacteria. So you may wonder, is this really going on inside me? Well, the answer is yes. It's happening every day. Bacteria and humans have a few things in common, but one of the most impressive is that they are able to communicate just like humans can. These single-cellular organisms are just as smart as us multicellular organisms. So you may wonder, how are these bacteria communicating? According to Kaneka-Leva and Plotkin, they communicate via chemical signaling, which is known as quorum sensing. Also, in a study found by Antunes and Ferriare, they found that bacterial species have been shown to be able to respond to signal molecules without producing them. That means that the bacteria can receive messages and not only send them. So that means that they're not only sending messages to our host saying, hey, I'm going to kill you soon, they're also receiving messages from other bacteria to know when to take over their host. An example of this might be telephone. The bacteria communicate back and forth just like in a game of telephone, sending signal to signal back and forth. So you may wonder, what are they communicating to each other? One thing they might communicate is about antibiotic drug resistance. According to El Hathaway and Valvano, bacteria can produce an info danger chemical that will tell other bacteria, hey, watch out for this drug, it might kill you, type of thing. The bacteria use this info chemical to know when the antibiotic is being introduced into the body so that they can watch their back pretty much. Also, another thing is how many of them there are. Bacteria like to colonize and lay dormant until they can kill their host all at once. The bacteria do this by what Winans and Basler say, monitor their own abundance in a local environment, just send the signals like back and forth in their environment. They can just tell when to take over by these signals by sending them back and forth. Also, by what Freestone found in 2013 was that microorganisms evolve sensors that detect eukaryotic hormones and allow bacteria to optimally time the expression of genes. Therefore, they can say, hey, you're sick, let me send this bacteria to help you. Your hormones would, of course, tell this bacteria through the signals it's sending, since, of course, the bacteria are also communicating through the same signals. In the long run, humans should evolve with the bacterium. We should use the bacterium signals to our advantage in our medicine and so forth. It may help us in everlasting health. It may help with heart disease. It could help with all kinds of things. Like, for example, say that we have a bacteria that chaps our lips. Well, we could say, hey, send out the good bacteria to kill the bad bacteria, or send out the good bacteria to unchap our lips and remove the bad bacteria. Therefore, we could keep the good bacteria and deny the bad. So here you see, bacteria communicate just like humans, and it's not as bad as it may seem, although it is happening inside of you. It may be a little bit different than us communicating, but quorum sensing is the bacteria's language. They can send signals about the antibiotics, they can take over their host all at once, and they can send the signal to each other and notice who all is there. It really is evolutionary. These single-cellular organisms should be given credit for their complex lives. Eventually, humans can be able to communicate with the bacteria, and medicine will better evolve itself. With all this being said, just remember the next time you're in a grocery store, in line at Starbucks, or on vacation, bacteria are communicating inside and around you.